Hi, today we're going to talk about exponential equations. So an exponential equation is an equation where the unknown value is a part of the exponent. For instance, you will have 2 to the power of x is equal to 16, or you may end up having that negative 4 times 1/3 to the power of 2x is equal to negative 72. So before we get into solving exponential equations, what we want to do is we need to understand a very important rule that you should have learned previously. So anytime you have a variable raised to an exponent, you have a power, or anything. It doesn't even have to be a variable. It could be a constant raised to a power. Anything raised to a power we call, or anything raised to an exponent, we call it a power. So here I have a power with a base b and an exponent of x. If I wanted to get rid of that base b and solve for x, all I would have to do is take the log of the same base, and then it will be equal to just x. And the reason why that is because exponents and logarithms, exponentials and logarithms are basically opposites of each other, just like addition and subtraction are. So if you take the log of one base and then you take it of something that already has the same base as the log, they cancel out. So let's look at an example. So it says solve the equation 2.1 to the power of x is equal to 8.4. So if I have it, I would need to take the log of both sides. But when I take the log, I have to take the log with the same base as the power. So I'm going to have log base 2.1 of 2.1 to the power of x is going to be equal to log base 2.1 of 8.4. So I know when I do that, the log and the base of the log with the base and that base of the power is going to cancel out. So now I know that x is going to be approximately, and then in order to put this into the calculator, I'm going to press math. I'm going to go to log base. It's going to be log base 2.1 of 8.4. And I will end up getting approximately 2.87. So in order to do this in the TI-84 calculator, we know that we can just put the left side in Y1 and the right side in Y2 like we do any other equation. And then we can find the intersection of the two. So when I do that, I'm going to have 2.1 to the power of x. And then for Y2, 8.4. And then I'm going to graph it. Because we are looking for the intersection, you always want to make sure that the intersection is on the screen where you can see it. So because we can see where the two colors meet, or the intersection, we press second trace and go to number 5, and we go up. Press enter 3 times, and we see that we get the same exact answer. So we still end up confirming that we have x is approximately 2.87. All right, let's look at example 2. So example 2, it says solve the equation 2 times 3 to the power of x minus 7 is equal to 21. So the first thing that I would do is I would add 7 to both sides, and that would give me 2 times 3 to the power of x is equal to 28. And then I would divide both sides by 2, which will end up giving me 3 to the power of x is equal to 14. And then basically I would have to take the log base 3 of both sides. So I would take the log base 3 of the entire equation, basically of both sides. So I would end up getting x on the left-hand side because I'm going to have to distribute that log through. So when I distribute the log base 3 to 3 to the power of x, I just get x. And when I distribute log base 3 to the 14, I end up putting that in the calculator so I can press math, go to log base. I'm doing log base 3 of 14, and that will tell me that this is approximately 2.40. That is what x is approximately in 3 sig fig. Once again, if I wanted to, I could use the calculator. So put my left side of my equation in y1. Put the right side of the equation in y2, and then graph it. Remember, if you cannot see both colors or both graphs, you will have to zoom in or zoom out accordingly. And because I can see one graph already, I'm just going to zoom out a little bit. So I'm going to hit zoom 3, and then I'm going to press enter. All right, so now I see both colors pop up, and I see where the intersection is. So I can press second trace, go to number 5, get as close as possible to the intersection, and press enter 3 times. And you will see that the x value is approximately 2.4, like we already said. So please make sure you understand that doing it in the calculator is easy, just like we've done the rest of ours equations before. So remember, you just literally put the left side in y1, put the right side in y2, and once you find the intersection, you just look at the x value, because remember, the x is the variable that we want to see or that we want to know. All right, so now let's talk about growth and decay. So when you start talking about growth and decay, you have to understand that the general form of an exponential function is written in the form of y is equal to k times a to the power of x plus c, where a and k have to be greater than 0 and a is not equal to 1. All right, so it says remember that when you are dealing with an exponential growth and decay, the initial value represents 100% of what you have. Whatever your percentage increase or decrease is, you must add to it or subtract it from 100. All right, so you always start with 100%. So for example 3, it says the value of an investment can be found by using the formula v to the power of n is equal to 1,800 times 1.12 to the power of n, where n is the number of years since the account was opened. Part A says what was the original value of the investment. So the original value of the investment is basically what was the value of the investment when you first opened the account. In other words, when your time or n is equal to 0. So if we plug in 0 into that equation, we're going to have y is equal to 1,800 times 1.12 to the power of 0. And when we put that in the calculator, we end up getting 1,800. So whenever I say what is the original value, that's basically saying what is the y-intercept. Okay, what is the y-intercept? That is all that it's saying. And remember, we are talking about money, so we have dollars. So part B, it asks, what was the growth rate? Meaning, what did it go up or down by? All right. So one thing that you have to understand is that anytime I say what is the growth rate, remember, you always start with 100%. So if we look here at this equation here, this is an example of an exponential function. But what you have to understand is that your A value is actually equal to 1 plus or minus R. Okay, so that means where you're increasing or decreasing. So if I look here, the value that is being raised to the exponent in this equation is going to be the 1.112. So if I know that A is equal to 1.112, then I obviously know that A is going to be equal to 1 plus 0.12, which tells me that my growth rate is equal to 0.12, or in other words, 12%. So that is my growth rate, 12%. That's how much it increased by. So now for part C, it says, find the value of the investment after 15 years. So all I have to do is just substitute in 15. So I'm going to have y is equal to 1,800 times 1.12 to the power of 15. So when I do that in the calculator, I end up getting that approximately there was $9,852.42 in the account for that investment after 15 years. Now part D, it says use the calculator to graph the value of the investment over time. And then we want to know how long will it take for it to reach $75,000. So my equation is 1,800 times 1.12 to the power of X, because we don't put it in there, we use X here, and we graph that. So as you can see here, I see part of my graph, but I can tell that I need to go over some. So I'm going to press zoom 0 because I want to fit it to the screen. That's zoom fit. And there I see the graph. So it says, how long will it take for the value of the investment to reach 75,000? So what that is saying is that I want my exponential function, I want the value to be equal to 75,000, which means that V of n is going to be equal to 75,000. And I want to see when that is going to be equal to 1,800 times 1.12 to the power of n. So in order to do that, I'm going to go back to y equals, and then I'm going to go down to y2, and I'm going to type in 75,000 there, and then I'm going to graph it. So now that I see both colors and I see where they intersect, I hit second trace, number 5, and I am going to zoom. I'm going to not zoom in, but I'm going to scroll all the way over until I reach that red line and where the red and blue meet. And then I'm going to press enter 3 times. And when I do that, I end up seeing that my intersection is located when n or x is equal to 32. So it says, how long will it take? So that's about, we can say about 32.9 years in order for that to happen. All right, if you want to say 33 years, that's fine. If you want to round it to the nearest whole number. All right, so now let's look at number 4. Number 4 states, Mark bought a brand new car for $35,000 in 2021. If the car depreciates in value approximately 14% each year, write an exponential function to model the situation. So it tells us that he bought a brand new car for $35,000. So if I write an exponential function, I know I'm going to have it as y is equal to, he starts off with 35,000, and the car is going to depreciate in value approximately 14% each year. So remember, you always start off with 100%. Okay? So basically, you want to decrease by 14% of your original value. So if I start off with 100%, that means I will have 1 as a regular number, and I'm going to subtract 0.14 because that's the percent that I'm subtracting each year, and I have to put it in decimal form. And I'm going to say that's going to be to the power of x. So if I simplify, I'm going to end up having y is equal to 35,000, and that's going to be times 0.86 to the power of x. And what that is saying is that every year I only have left 86% of my value, because 14% of my value is going to basically, I'm going to lose that amount, which means that I'm going to repeatedly multiply by 0.86 each time, because every single time I'm losing 14%, which means I only retain 86% of, which means the multiply of what I started with. And we know that when we have repeated multiplication, that is the same thing as having an exponent. So now it says, how much will the car be worth in 2029? Well, what you need to realize and understand is that in 2029, we already said that he bought the car brand new in 2021. And we know that X is the number of years since 2021. In 2029, that means that X will need to be equal to 9. Because 2021 is when X is 0. And it's going to be when X is equal to 8. So in order to find that, all I have to do is substitute in 8 into the function. So I'm going to have y is equal to 35,000 times 0.86 to the power of 8. And then I will get that it is approximately going to be worth approximately $10,472.63. All right, and last but not least, it says, in what year did the value of the car reach 16,000? So in order to do that, I'm basically saying that I want to have 35,000 times 0.86 to the power of x. I want it to be equal to 16,000. And we know that in order to find that, we can do the left side in y1 and the right side in y2. And we will end up getting and when we graph it, we will end up getting the following graph. And of course, remember, you want to make sure that you can see both of the colors or both of the functions when you graph it. So yes, we can here. So I'm going to press second trace, go to 5, which is the intersection, and I'm going to get as close as possible to the intersection as possible. And I see that we will end up having that X is approximately 5.19. And that of course, remember, that is the number of years, because remember, X represents the number of years since 2021. So if we say 5.19 years since 2021, we're basically adding that on. So 2021 plus 5.19, that will actually end up giving me 2026. And we don't have to say 2026.19. It just means that we're a little bit past January or February. All right. So basically, you take the beginning year and you add the amount of years to it, which will put us approximately in 2026 when that happens. All right. If you have any questions, please ask your teacher or ask me, and I will be more than happy to assist you. Have a great day.